Let's prepare on the TRB Polytechnic exam 2012 Civil Engineering question paper. Question number 1. Static equilibrium implies that the forces have zero resultant and also the zero moment. Question number 2. Working stress of milestone is determined from the dash. So here lower yield stress, that is we will be drawing a stress strain curve for the milestone. No? So from that the lower yield stress only will be taken as the working stress. And then question number 3, compatibility conditions are essentially required to solve the redundant frame. Question 4, the maximum number of unknown forces that can be determined in a concurrent force system under equilibrium is 2. And then 5, the portion AB is subjected to a force equal to what? Okay, so if such questions are given, means you should always start the calculation from the ends, from any end. Okay, so here in the left side end no force is given, but in the right side they have given us 100, so we can fix that as 100. Okay, so we can fix here 100. This is for BC. Okay, but in this point B they have given 200 kilonewton in the left direction, but we already have a 100 kilonewton in the right direction at the point B. Okay, so it means that it should be added together, and the side, that is the direction, is towards the bigger number. Okay, so here it is 200 plus 100, so you will be having 300. So when 300 is present there, means only this 300 minus 100 will give you 200 in the left direction. So here 300 should be there in this point, and in this point also 300 should be there, so that the AB member will be having 300 kilonewton force. So option B is the right answer. Question number 6. If the Poisson's ratio is 0.3 for a material, the ratio of Young's modulus to shear modulus is what? And you can see the question number 7 also. Here they have given the ratio of Young's modulus to bulk modulus is given, and they have asked the Poisson's ratio. There Poisson's ratio they have given and asked the ratio. Here ratio they have given and asked the Poisson ratio. But you can clearly see that the Poisson's that is the ratio is for the Young's modulus to shear modulus in one question, and in the next question it is Young's modulus to bulk modulus. So these two formulas we will be studying in the same chapter, the first chapter of strength of materials. So we will be seeing that together. So in question number 6, it is between E and G, no? So E is equal to 2G into 1 plus mu. So this is one formula. And in question 7, it is E is equal to 3K into 1 minus 2 mu. So these are two relations, and another two relations also we are having for finding this mu, E and K, everything. Okay, so first we will see that. In the first question they have asked the ratio of E and G, no? So E by G will give you 2 into 1 plus mu. So mu is 0.3, so 2 into 1.3, the answer is 2.6. And in the next question they have given the ratio and asked the mu value. So here we can write like this, that is E by K is equal to 3 into 1 minus 2 mu is equal to 1.8. So that 1 minus 2 mu is equal to 1.8 by 3. So that it is minus 2 mu is equal to 1.3, that is 1.8 by 3 is, it is nothing but 0.6. So 0.6 minus 1 will give you 0.4. So in this minus you can neglect it, in the both sides it is there. So 2 mu is equal to 0.4, so mu is equal to 0.2. So answer is 2.6 for 6th question and 0.2 for 7th question. Question number 8. The radius of the Mohr circle for stresses at a point in a body to sigma x is given minus 160 Newton per mm square and sigma y is 350 Newton per mm square. They have asked the radius of the Mohr circle, and they have given that tau xy is equal to 0. So whenever tau xy is equal to 0, the formula is sigma x minus sigma y by 2. So that is the simple formula here. Okay, so you can directly do that, minus 160 minus 350 by 2. So you will be getting 510 divided by 2. So it is 255. Option A is the right answer. So this is the radius, so we can neglect the minus here. Question number 9. For a beam carrying a UDL, the strain energy will be maximum in the case of the beam When it is a cantilever, simply supported, propped cantilever, fixed at both ends and everything. Okay. Here we don't have a straight formula for finding the strain energy for these type of beams, but we can relate it with the bending moment. Actually, strain energy is directly proportional to the bending moment, so that we can find the bending moment for all these beams and we can relate to this answer. So this is the bending moment for cantilever. It is WL square by 2 and simply supported, and also the propped cantilever for both it is WL square by 8, and for fixed beam at the ends it is WL square by 12 and the center it is WL square by 24. Okay. So if we consider all of these 4 beams, for cantilever only the bending moment is maximum. It is WL square by 2. So it means that the strain energy also will be maximum for the cantilever beam. So option A is the right answer. Question number 10. Two uniform steel rods A and B of same length having diameters D and 2D are subjected to tensile forces P and 2P respectively. Then the strain energy in both rods will be what? So here just we have to do the ratios of these so that we can tell which rod has more strain energy. Okay. So here the length is same but the diameter and P, that is the forces, differing here. So we will see the formula first. So here the strain energy formula is actually half into P into del. So the del can be written as PL by AE. So the combination it is written as P square L by 2AE. Okay, so here the length is same they have given, and about E they have not given anything, so we can keep that E is also same for both. So we no need to worry about this L, E and 2 because it is common for both. The only differing thing is P and A is going to differ here. So let us concentrate on that alone because we just want to know what is the which is greater or what is the relation between that two rods. Okay, so that is enough. So here in the first rod, if you take beams, the force is P only and the diameter is D only. So if the area is pi D square by 4, no, so here D is D only. So it can be written as A itself. So P square by A you will be getting. In the second formula, for P it is 2P. Okay, so 2P the whole square it is 4P square, and also for D it is 2D. Okay, so pi D square, no, so in that 2D square means it is 4D square, so the 4 will be coming out, so 4A, and again the 4 and 4 will be cancelled and it is again equal to P square by A. So it means that both the rods are having the same strain energy. So here option A is the right answer. Thank you and keep watching.